All right, so today we are going to transform parabolas. We have a basic parent function. It's a basic parabola. It's called the parent function. It's y equals x squared or f of x equals x squared. We're going to go ahead and graph that out. Some values I'm going to pick here are -2, -1, 0, 1, and 2. So if I take -2 and I'm going to plug it back into that function of x squared, so I can take -2 squared and I get 4. I can take -1 and I can square it. Noticing when I'm squaring it, I'm putting parentheses around it. So you want to do that when you've got a negative there. You don't have to do it when you got a positive. You do have to do it when you got a negative there. So I can go ahead and I can plot that out. -2, 4. -1, 1, 0, 0, 1, 1, 2, 4. So there's my nice y equals x squared graphed out. So doing some transformations of these, we can do those as well. I'm going to pull up the graphing calculator here so you can see them graphed out. And if you've got a graphing calculator, you can go ahead and do that on your graphing calculator as well. But let me find it here. So the first one we're going to plug in there is y equals x minus 2 squared. Here it comes. Coming up. There it is. So what I'm going to do is I'm going to go to my y equals here, and I'm going to clear this out of here. And my calculator is all set up. I'm going to my window here, and I'm going to reset that. I'm going to say -10, 10, 1. And keep doing that. -10, 10, 1. And now I'm going to go to my table set, second window here. And I start off at 0. I'm going to have my table there go by increments of 1. So once I have that all set up, then I can go to my y equals up here, and I can plug in whatever I want. And I believe the first one I have up there is x minus 2 squared. So x minus 2 squared, correct. So looking at that, I'm going to graph that out. So normally our other one there, and I should actually plot that out first. Here, I'll do this differently here. I'm going to clear this out of here and do this one more time. I'm going to plot x squared. And then down here, I'm going to come down here one more time and I'm going to plot the other one. X minus 2 parentheses squared. So we can compare the two. So it's going to graph the y equals x squared here first. There it is. Sitting there at 0, 0, vertexes. And the other one, notice from the other one, it shifted 2 to the right. So that's what I'm going to say here. I'm going to say this one here is right 2. So knowing that, inside there it's x minus 2, we're going to shift it to the right 2. The other one here, if I graph my other one here, I'm going to put in down here. I don't always like this. There. Parenthesis x plus 2 squared. Let's graph those and see what happens. So there's y equals x squared, and you can see that x plus 2 made it go to the left 2. Left 2. Now, what do you think about this one? Now it's not inside the parentheses. Number 3 there says x squared plus 3, and there's no parentheses around. The other one had parentheses around the x plus 2 and then squared. This just has x squared plus 3. Which way do you think that will move it? So let's go to our graphing calculator here, and let's plot that one out. So this one here is x squared and then plus 3. Hit graph. There's the first one. How does the other one compare? Oh, it's just moved it up 3. Up 3. Shifted it up 3. So what do you think about number 4 there, x squared minus 3? I'm kind of thinking, oh, the other one went up 3. This one's probably going to go down 3. So I'm going to punch in x squared minus 3. Let's see if that's true. So comparing with y equals x squared, there it is. What's the other one do? Yeah, just down 3. Shifted the whole thing down 3. Now the next one's going to do a combination of things. Inside here, you're adding 1 for number 5 in there, and then on the outside there, you subtract 5. So we got to figure out 2 different moves. So I'm going to go to my y equals here. I'm going to plug in my new one here, which is x plus 1 parentheses squared minus 5. I'm just going to double check, see if I did that right. Yep. I'm going to hit graph, and we're going to compare it that one. So that one, if you can tell, the vertex is sitting kind of like right here. So it looks like to the left 1, and then down 1, 2, 3, 4, 5. So looks like negative 1, 5. So it looks like moved left 1, and then down 5. Left 1, down 5. And that, again, if you got a plus inside here, notice number 2 there is like it. What happened with number 2? You had plus 2 and moved it to the left. You've got a plus 1 in here, it moved it to the left. And our other one in here, on the outside of the x squared here, you had a minus 3, so it moved it down. And then on the outside here, you had a minus 5, so you moved it down 5. So just kind of comparing those. Number 6 there, a little difference, got a negative on the outside there. Let's compare those. So I'm going to go down here, plug this in. I'm going to plug in a negative x squared and see what happens with those. So there it is, and there's the next one. Oh, it's just upside down. Well, of course, got a negative on the outside, it's going to flip it upside down. So flip upside down. Some people like to say it's reflected over the x-axis. However you want to do that. And then your last one here has a 2x squared. That kind of looks like a slope. So let's go over here and plug in that one. I'm going to delete that out of there. So 2x squared. Enter. I'll hit graph. Notice this one just made it narrower. It changed the slope of it. Before it was like negative 1, 1. Now it's going to be negative 1, 2. And before it was 1, 1, 1. Now it's going to make it 1, 2. So that's how it's going to change there. So it makes it steeper or narrower, more narrow. Or people think vertical stretch factor by 2. Those are our transformations. So knowing that, we're going to go ahead and graph those. So it says for each find the coordinates of the vertex, the y-intercept, and graph it. So if we're looking at this one, x minus 4 squared, we said that minus 4 inside here was going to go ahead and move it to the right 4. So kind of thinking about your parabola sitting here at 0, 0, and you're just going to move it over the 4. Or you could just graph out your parent function here first if you wanted to. Our parent function here was 0, 0, negative 1, 1, 1, 1, and then we had 2, 4, and negative 2, 4. And what you want to do is you want to shift each of these ordered pairs over to the right 4. So I can do that. 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and connect them. So um, there's what are the coordinates of the vertex? They are going to be 1, 2, 3, 4. So vertex 4, 0. And then the y-intercept, I'm not really seeing it. So the way you can find the y-intercept when it's in this form, you want to um, put in x equals 0. So I'm going to do that. I'm going to put 0 in there for x. So y equals 0 minus 4 squared. Well, 0 minus 4 there is -4 squared. I get 16. So my y-intercept there is just 16, or 0, 16. However you want to write that. If you want to write as an ordered pair, it'd look like this. And we already graphed it. So there's a nice little graph. Let's look at another one here. It says, for each, find the coordinates of the vertex, the y-intercept, and graph it. So this time here, you got a +4 in here. So we know that moves it left 4. And on the outside here, we have a -2. So we know that moves it down 2 from our patterns from before. So if we want to graph our parent function, 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. So that's what we did on the very first slide. We graphed out that. Now we're going to move everything. So we're going to move every point there, left 4 and down 2. So 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. So I can connect them, and now it doesn't look like a nice smooth parabola like that. We know we messed up. So left 4 and down 2. That is not left 4, that is down 2, is it? That is right 4, down 2. So I'm going to get rid of that, and I'm going to regraph it. So my other one here, check and see if we're really paying attention here. Just kidding. So left 4, 1, 2, 3, 4, down 2. Left 4, 1, 2, 3, 4, 1, 2. Left 4, 1, 2, 3, 4, 1, 2. This one here, left 4, 1, 2, 3, 4, 1, 2. Left 4, 1, 2, 3, 4, 1, 2. Connect my points. So there, the green graph there is our final graph. And then we have to find the y-intercept. Y-intercept, let x equals 0. So I'm going to plug it in there. Y equals 0 plus 4 squared minus 2. So inside here I get 4 squared minus 2. So that's 16 minus 2, which gives me 14. So 0, 14 would be my y-intercept, or just 14. And the coordinates for the vertex, let's identify that part. Vertex is this nice point right there. So 1, 2, 3, 4, 1, 2. So what is that? -4, -2. So I'm going to go ahead and stop there.